Welcome to Click Academic on our series of video tutorial on set and number systems under mathematical induction. So in our last class, we were able to solve one example. So today we are going to solve this example to learn more about mathematical induction. As we have said earlier, that mathematical induction is a skill that we normally use in order to test the validity of any given mathematical expression or equation. So therefore, this example, we are going to show that what is here is equal to what is here based on the validity of it. So therefore, as we know, let's say solution. In mathematical induction, we have 3 steps. Let's start with step 1. Step 1 said to prove that the statement is true for n equals to 1, 2. Therefore, what we are saying, the statement is true, meaning this statement is true that this equal to this for n equals to 1 and for n equals to 2. Then for n equals to 1, our left hand side, now in this left hand side, this is our left hand side. What is the first term? Is a. Therefore, it's equal to what? A. Then in our right hand side, we are going to, anywhere we see n, we are going to put 1. Then here is what? A upper 1 minus this all over r minus this. This is something as what? A from bracket r minus 1 all over r minus 1. Now this, they will go. What will left is what? A. Therefore, our left hand side is equal to the what? The right hand side, which is equal to what? A. Therefore, 1 satisfies the condition. Then for n equals to 2, then we should test for n equals to 2. Now, in our left hand side, we are going to pick 2 terms, the first 2 terms, this and this. They are the first 2 terms, which we have a plus ar. Now, this a plus ar, you see something is common, you can factor it out. We may have what? A into 1 plus r, right? So therefore, in our right hand side, which we may have what? A into r squared minus 1 all over r minus 1. Now, if you look at this r and this is the same thing as 1 squared. Because you know that 1 power anything is just 1. So therefore, this is the same thing. And if you look at this, it's different of 2 squares. So we may have what? R minus 1 and r plus 1 all r minus this. So therefore, you see that this will go with this. We are left with what? R with what? 1 plus r. Now, I told you earlier that the plus is commutative. You can twist it. So therefore, if you look at this and look at this, they are what? You find out that they are equal. Therefore, the left hand side is equal to the what? Right hand side, which is equal to what? Is equal to a into 1 plus r. So therefore, the statement is true for the first steps. So now we move to the second step, step 2. Step 2 said to assume that the statement is true for n equals to k. Therefore, in this statement, anywhere we see in this statement, anywhere we see n, we are going to replace it with k, which is what? A plus ar plus ar squared plus ar cubed plus dash dash plus what? Ar n minus 1, which is equal to what? A into what? Here should be k, I'm sorry. Then here should be what? R power k minus 1 all over r minus 1. So now this is all about this. Then we now go to step 3. Step 3 says to prove that the statement is true for n equals to k plus 1. Now, what from here to here, this is our k term. Then we need to have the next word term after, which is k plus 1 term. R squared plus what? R cubed plus dash 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 plus what? R k minus 1 plus what? R power k. Now, if you add 1 here, it will only be k. That's what is our next term. Now, if you look at this place to this, they are all equal. So therefore, and this is equal to this. We can easily remove this and replace it by this in our expression. Now this will be equal to what? We have a into r power k minus 1 all over r minus 1, then plus r power k. Now look at this is our next term. Then we now take the LCM. We have r minus 1 into what? Here it should be what? A into r power k minus 1 plus r power k into what? R minus 1. Now this time this, you have what? R power k. This time this is minus a. This time this, you have what? Plus a r k plus 1. Then this time this, you have minus what? A k, where r power what? K. Now this is the expansion of this. This is the same thing as what? R minus this. Now if you look at this, this time this, you have this. This time this, you have this. And this time this, you have this. This time this, you have this. So now if you look at this time and this time, they are the same. And we have negative, so this will go with this. We are left with what? Now this is minus and this is plus. So we take minus first and leave the, this positive, the negative letter. Minus a all over what? All over r minus 1. This is the same thing. If you look at this, a is common. We'll just factor a out and have r power k plus 1 minus 1 all over what? R power minus 1. This is as required, is proved. Because if you look at the first statement given to us, we have what? A into r power n minus 1 all over r minus this. So we are told that anywhere we see n, we are expecting to see k plus 1 as required here. So therefore, this is the end of our lesson of today. Thank you very much.